Lesson 2.3 is on multiplication of positive and negative fractions. Our first little key concept here to help you out is to multiply fractions. Multiply the numerators and multiply the denominators. So if you look at this first example, you multiply your numerators. 2 times 4 gives us 8, and 3 times 5 gives us 15. So that's how we multiply fractions. Pretty simple, pretty basic. Another thing that you might want to take into consideration is reduce your fractions prior to multiplying. This is the big hint. Look diagonal. If you cannot reduce your fraction right away, such as 2/3. 2/3 is reduced, right? So if you can't reduce that, you need to look diagonally in order to reduce. Just remember, whatever happens to a numerator needs to happen to a denominator. Whatever you do to the top has to be done to the bottom. So on that being said, what you do to a numerator has to be done to a denominator. Our first example here, we have 3 7s times 8 9s. Now if we look at our first fraction, 3 7s, you cannot reduce 3 7s. Check out your second fraction, 8 9s. Cannot reduce 8 9s. So now you need to look diagonally. When you look diagonally, you would see that you can reduce that. There's the diagonal. Whatever you do to a numerator can be done to a denominator. We know that a 3 can go into both of these. So a 3 goes into 3 one time. A 3 goes into a 9 3 times. Now we've taken a 3 out of your numerator and a denominator. And now you can go ahead and simplify here. So I should say multiply. So we take our 1 times 8, because really our fractions look like this, 1/7 times 8/3. Multiply your numerators. 1 times 8 is 8, and 7 times 3 is 21. So we wind up with 8/21. Next example, 2 7s times 8 9s. Again, can't reduce those fractions right away, so now we look diagonally. When we look diagonal, we notice we cannot reduce diagonally. We cannot do 2 and 9 or an 8 and 7. So you go ahead and multiply. In this case, we get 16 over 63. 16 63rds. Multiply the top, multiply the bottom. Next example, example 3, we have 2 9ths times 8 9ths times 7 12ths. Okay, all these fractions cannot reduce. 2 9ths, 8 9ths, 7 12ths can't reduce. So we start looking diagonally. Well, I can take a 2 out of this numerator, and I can take a 2 out of that denominator. I've done something to a numerator, then I need to do something to a denominator. So I'm going to take a 2 out of each. This now is a 1, and this now is a 6. Look again diagonally. Well, I can take a 7 out of my numerator, and I can take a 7 out of my denominator. This is now 1, this is 1. Still looking diagonally, I can still take something out. In this case, I can take out a 2. Well, I take a 2 out of this, leaving me with 4. What I take out of the top, I need to take out of the bottom. So I took a 2 off the top, I need to take a 2 off the bottom, which would wind up giving me 3. Now, I can't do anything. I have a 1 4, a 1 on top, and I have a 1 9 and a 3 on the bottom. Now I can go ahead and multiply. 1 times 4 times 1 is going to give me 4. 1 times 9 times 3 gives me 27. So I wind up with 4 27s. Now, same situation here, multiplying negative fractions. Same concept, and you're tying your positive negative piece into it. So right now you have a negative fraction times a positive fraction. You should get a negative outcome. So negative 3/4 times 7 12ths equals negative something, because a negative times a positive is a negative. So you look at your fractions, can't reduce, so we start looking diagonally, and we can reduce diagonally. We can take a 3 out of the numerator, and we take a 3 out of the denominator, so winds up with 4. We do our multiplication here. 1 times 7 is 7, and 4 times 4 is 16, giving us negative 16 or negative 7/16. 2. Negative times a positive is going to give us a negative again. We look to reduce diagonally, which we're able to. We can take a 5 off the numerator, and a 5 can go in our denominator. We go ahead and do our multiplication. We wind up with negative 2 27s. Next example, example 1. When we see this, here's our mixed numbers. When we work with mixed numbers, go ahead and convert them. Multiply, add here, multiply, add here. 3 1/5 converts to 16/5 times 7/4. Positive times positive will give us a positive outcome. Look to reduce diagonally. Again, we're able to reduce diagonally. A 4 can come out of here. 4 can go into 16 4 times and into here once. Do your multiplication, giving us 28/5. Next example, again, mixed numbers, convert them. When we do our conversion here, we're going to get 17/5 times 20/9. Figure out where we can reduce within our problem. Well, reducing diagonally here, we can take a 5 out of here, giving us 4. Take the 5 out of here, giving us 1. And we can't reduce anywhere else. 17 times 4 is going to give us 68. And 1 times 9 is going to give us 9. So 68/9. And our last example here, a little word problem example. Volunteer work. Last summer, the 7th graders performed a total of 250 hours of community service. If the 8th graders spent 1 1/5 this much time volunteering, how many hours of community service did the 8th graders perform? Gives you a little synopsis here. It says the 8th grader spent 1 1/5 the amount of time as the 7th graders did in community service. If they spent 1 1/5 the amount of time, 1 is representing the whole, which is 250. So we need to figure out a fifth of that. So basically what's happening here is they outperformed the 7th grade class. In order to figure this out, here's what the 7th graders volunteered. That's your fraction. 250 over 1. So 250 hours. The 8th graders had more than that, so we're multiplying by 1 1/5. Do our conversion here. We have 250 over 1 times 1 1/5 converts to 6/5. We look to reduce diagonally. When we reduce diagonally here, we know a 5 can go into here once, and a 5 can go into 250 50 times. Do your multiplication. 50 times 6 is 300 over 1, which would equal 300 hours of community service the 8th graders performed. This concludes lesson 2-3, multiplying positive and negative fractions.